Well, hello everybody. I hope you're all really good this week. This is what we got. I know you guys all hate ATX Power Supplies, but I'm going to drag you to them kicking and screaming and we're going to work out how to fix them. These are quite complex to repair, which is what I think puts a lot of people off going anywhere near them. But I bought the two of these from a guy on one of the second-hand sites, and our postal service on post here in Ireland took very good care in bringing them to me. See that? They took it out of the box it was in, put it in some sort of Christmas paper, and then stuck a sticker around it to say damaged in transit and threw it through the door. And as you can see, it seems that they kicked hell out of this one. I don't think that's meant to be at that angle. I think that's meant to be a right angle. But look, they're normally good. I'll forgive them this one, especially given that the two of these were broken already. So what I'm going to do is I'm going to take this one first. This is the, I don't even know how you pronounce this, EVGA, is it? 1000 watt power supply. So this is a gaming power supply. It's modular as well. I've already taken the cover off it. And as you can see, with these ATX power supplies, there are a million components in it. Now, I'm probably biting off more than I can chew here, but what I'm going to do is check the basics to start with, and we'll see if it looks like it's something that we can make progress with. So why don't you come along for the spin?
Okay, so the first thing I decided to do was to measure and see if we had our 5 volt standby voltage. Now you can check this on the 24 pin connection that goes to the motherboard. This is the same 24 pin connection that's on most of the ATX power supplies, and I've got our pinouts here that I've taken down and marked on each of the pins. So what we need to do is find the pin that is the 5 volt standby, which is this pin right here, and measure the voltage on that. So just to be clear, I have the power supply plugged in, but I haven't done anything to switch it on. So we're checking to see if we have our 5 volt standby. So I introduce my digital multimeter in the 20 volt range, and then I get my black probe and I place it to any of the ground pins. You have to dig that in a little to make sure that it makes contact. And the same with our 5 volt standby, which is right here. So when I measure the standby voltage, I was measuring something like 2, 2.5, 3. It seemed to fluctuate, but it wasn't the correct 5 volt that I would be expecting if the standby voltage was working. So it seems like there are serious problems for this power supply. Even before I try to switch it on, the standby isn't even working. So I need to remove the motherboard. I need to remove the board, the main board, from this ATX power supply, and I'm going to take some pictures and I'm going to bring you through the next troubleshooting steps that I took. I need to put in a quick disclaimer at this point, guys. These boards on the switch mode power supplies are extremely dangerous to work on, so please do not work on these unless you have taken the appropriate security precautions and you have the appropriate training to do so. Thanks. And with that said, I'm going to show you where I started troubleshooting. So you may remember from the last time when I began troubleshooting the previous ATX power supply, I start right from where the mains voltage comes onto the motherboard. So I identified these two pins from the top side as being the two pins that carry the AC onto the motherboard. So what I'm going to do is I'm going to mark in those two pins what they are, and I'm going to trace it as it makes its way up to the bridge rectifier. The bridge rectifier we can see as being these 4 pins in a line right here. So let me mark that out now. Before touching this board, I plugged it out and I discharged the main filter capacitors on this as well to make sure there was no residual voltage. So I observed from the top that our black wire came through here. So the black wire, I think, is that was the American for live, and the other one is the neutral, which is white, and came through here. So our live wire is through here. So let me mark that in. And then I traced it across the board. So it went from here to here. That's actually the fuse. And then I followed it across this path to here, and onto the center pin of the bridge rectifier. So that's the path that our live takes. Next, I'm going to plot the path of my neutral wire. As I said already, our neutral wire comes through here. So I'm going to use my pen tool to mark the path of this. Whoops. So that's from here to here. I'm not even going to get bogged down with trying to identify what those components are, because what I first want to identify is to verify that there's continuity between the neutral wire and one of the center pins of the bridge rectifier, and the live wire and the other center pin. These rarely fail, to be honest, so I'm expecting to find continuity between here and continuity between here and here. So let's test for that next. So I introduced my multimeter in continuity mode, which looks like this on my multimeter. And once again, it's plugged out and I've drained all the voltage from it. That's the only time you can use continuity mode. So I place my red probe to my live wire where it enters there, and I place my black probe to one of the center AC pins on the bridge rectifier. And when I do that, it beeps. So we do have continuity between where the live wire enters the board, across the fuse, and across a couple of inductors, I think, and straight onto the center pin of the bridge rectifier. The second wire is the neutral wire, which comes in here. So again, in continuity mode, I place my red probe here, and I place my black probe to the other center pin of the bridge rectifier. And once again, it beeps to say that I've got continuity between these points also. So that all looks good. Now, some people might say, why don't you just measure, why don't I just switch the multimeter to high voltage AC, turn the thing on, and place my probes, to the two center pins here, which is what a lot of people do. I don't like doing that. I try and put safety first. And what I find is if you're measuring for 230 AC across these, there's too much of a chance of these pins or these probes slipping and touching off each other, and as well as endangering yourself, it will also cause more damage to the board. So that's the reason why I switch off the power, drain the main filter capacitors, and use continuity mode here, because I just think that it's safer. So we verified that it's good up to the bridge rectifier, so now we need to verify that the bridge rectifier is doing what it should. Just marked in the 4 pins on that bridge rectifier there, so we have verified continuity for the 2 AC pins in the center. Now we should be expecting about 230 volts AC across these, and then the diodes within the bridge rectifier rectify that from AC to high voltage DC, and that voltage in DC should be, it's usually around 310 to 320 volts. So it is possible to measure that voltage here, but I don't usually like measuring it at this point because there's a lot of pins around and you can cross them and cause more damage pretty easily. Again, I do take a safety first approach. The easiest place to measure that high voltage DC is at the main filter capacitor. So let me identify where the main filter capacitor is on this board. Now there's actually 2 on this board. So the largest capacitors on the board, have a guess which they are. It's very easy to identify them. So you can see that these are the 2 main filter capacitors right here. And if you look back on the board, they come through to the other side of the board right here. So that's where I'm going to measure for our 320 volts DC. Okay, at this point I plugged in my power supply. I changed my multimeter to the 1000 volt DC range because we're expecting a very large voltage here. Then I placed my black probe very carefully to the ground side of the main filter capacitor, and the red probe to the positive pin of that same capacitor. And when I measured this, I got a surprise because it was only measuring 10 volts and slowly rising at this point. So I checked it a number of times because I didn't really believe it, but sure enough, that's what I was getting. 10 volts, very slowly rising to 12, very slowly rising to 15. But there should be 320 approximately across this all of the time. Now this made me happy because the likelihood then is that the problem lies somewhere between that filter capacitor and our input back across here. So this again made me confused because I've already verified up to this point. So I was then thinking possibly, is there an issue with the bridge rectifier? Now before checking the bridge rectifier, I just wanted to carry out one more check. So I plugged out the power supply and I discharged the main filter capacitors, and I wanted to carry out a test for continuity between the V positive of the bridge rectifier and the positive pin of these two main filter capacitors. So I switch my multimeter to continuity mode again, which looks like this on my multimeter, and I place my red probe to the positive pin of the bridge rectifier, and I place my black probe to the positive pin of my main filter capacitor, and there was no continuity. Now I know that there is a relay in here somewhere also, as well as a thermistor, but I felt that it should still be continuous from the positive pin of the bridge rectifier to the main filter capacitor. So I decided to check what was along the path here. And what happened was, when I flipped the board over, I observed the following. Now, some of you may have observed this yourselves, but can you see that there? That's the thermistor. And you can see from there it looks like it's blown up. I've got a quick video to show it a bit closer. Let me just show you that now. This is a close-up of the damaged thermistor. So you'll see when I focus in, it's completely exploded, so I have no chance of identifying the component from the markings on it. We don't have a schematic, so I can't identify the component that way either. So what I'm going to do is I'm going to borrow a thermistor from another 1000 watt power supply that I have here. I'm going to swap it into this board and see if that brings it back to life. If it does bring it back to life, I'm then going to try and find out what the exact component was that was originally in this power supply. But let me swap in the other one first and see if I can get it working. The replacement thermistor that I borrowed was an SCK2R58, just in case anybody's interested. So this is what it looked like with the replacement thermistor. You can see it there, all clean and shiny. Now, there was a capacitor behind it that looked like it was damaged, but that was actually just the remnants of the old thermistor. So with the new thermistor in, I wanted to jumper it on and see if it was working, and that's what I did next. After replacing the thermistor, I wanted to check for standby voltage again. So I plugged in the power supply and I placed my black probe once again to ground and my red probe to 5 volt standby. And this time, after replacing the thermistor, there was 5 volt standby present. We verified that standby voltage is good, so the next test is to power it on and see if all of the main voltage rails come online. Now, you can plug the power supply into a working motherboard to do that, but you can also jumper the PS on pin, which is this one here, to ground, and that will do the same thing. So I got a paper clip and I jumpered PS on to ground like this, and then I left my multimeter connected in volts DC, connected like this to check the 12 volt rail, and then I plugged in the power supply again, and this is what happened.
Okay, so this is my 24 pin connector. You can see that I have jumper to PS on to ground with a paper clip, and over here on the right I have my black probe to ground and my red probe to what is the 12 volt power rail. And as you can see, the power supply is on and producing a very stable 12.25 volts. So it looks like the power supply is working. I will double check all of the other voltage rails as well, but this certainly looks good.
I checked all the other power rails and they're all fine as well. So it looks like we have a working power supply now by simply just replacing that thermistor. The thermistor I have, I'm sure, is probably fine, but I'm going to find out for sure the exact value of the thermistor that was on the original one, and I'm going to post that down in the details below. So I will update it in the description if anybody else is following along to try and repair their own. That's all I got for this week, guys. I just want to say thanks to everybody who's liked and subscribed so far. I'm nearly up to the milestone of 1k subscribers. A little bit to go yet, but hopefully it'll roll over pretty soon. I'm going to keep doing this until I hit 100 videos, and we'll see where we take the channel from there. Keep tuning in, and I'll see you next week.